Hi everyone and welcome to Space Study Program. I first like to take this opportunity to thank Dr. Hatamli, the CIO of NASA and International Space University for inviting me to this amazing event. And I'm sorry that I cannot attend in person. However, I'm going to take this opportunity to share some thoughts with you about innovation for space. Let's get one thing straight right away. Space is hard, and it's hard because of three reasons. First, space is really far. The closest thing that you can imagine to orbit the Earth is about 300 kilometers away. Mars is about millions of kilometers away. Second, space is really empty, so there is no one around to go and fix your mistakes. Everything has to be perfect before it goes up there. And third, space is really harsh. We are talking about hundreds of degrees temperature variations, extreme pressures, and radiations. So, how do we innovate for space? Well, based on all of these challenges that I just told you, when you're innovating for space, you have to hope for the worst. This means that you need the best of engineering to make it out there. But this shouldn't discourage innovators and inventors. Because when you're thinking about outer space, you also have to think broad. I think what people don't realize is how broad the spectrum of innovation is for outer space. Almost everything we take for granted here on Earth can be reinvented for outer space. And this means a massive innovation opportunity. There are a lot of facets to space exploration, and space is not just about bigger rockets and better satellites. Space is also about optics, robotics, computer sciences, and more chemistry and biology. And this is what brings me to my next innovation strategy for outer space. That is to adapt the cutting-edge technologies to space applications. We do need this adaptation because most technologies are developed without having any space application in mind. And this change of context to space can actually open a lot of new possibilities. And here's where being imaginative can help. For example, how can machine learning and artificial intelligence help us find alien life forms, or black holes, or other subjects of interest in outer space? How can we have drones that can fly in thin atmosphere of Mars? Can the lower gravity help us enough to have a flying drone that can cover much longer distances than the ground-based rover? How can quantum optics help with the long-range communication in space? Can the extreme condition of space actually help to realize that? Considering the low pressure, is it possible to have inflatable gaseous solar cells in outer space? Etc., etc. So you can come up with a lot of concepts like this and start to get real ideas. There are these big moonshot projects that usually get a lot of media attention, but I think it's always helpful not to get distracted with those and actually step back a little and ask what comes before that big moonshot project is realized. This is a technique I call the dial-back technique, and it actually works pretty well for a wide range of technologies. For example, in case of autonomous cars, you could have asked, years ago, you could have asked, what comes before an autonomous car? The answer might have been, well, maybe a fleet of autonomous robots operating in a more predictable, controlled condition. Bingo, that's the core concept of Amazon's warehouse. Or the answer might have been, well, maybe autonomous navigation system, which is the core of Uber. What comes before flying cars? Well, a lighter version flying robot, which is basically the concept of drone, and that's the core of the drone industry that we have today. So as you can see, each of these intermediate steps opens new lines of thoughts that would be undiscovered if you were just focusing on that big end goal. You can use the same dial-back technique when thinking about space. For example, you can ask, what comes before we colonize the Mars? Can we have a station between Earth and Mars? And would that be able to help us in this travel? What kind of infrastructure do we need before we send a human to Mars? And with regards to alien life forms, you can ask, for example, what comes before we find an intelligent life form. Well, obviously a non-intelligent one. So how do we find these plants and microbes in a planet that is far, far away? Is it enough to analyze the gas combination and using some sort of spectroscopy as such? So this is where you start to find real ideas. If you think too far ahead, you won't be able to make it practical. Space is exciting for those who can afford it. And by affording, I mean both intellectually and financially. If you cannot communicate and convert your excitement to other people's interests, you will be left alone with all of your amazing ideas. And that actually happens a lot in academia. So in order to make it practical and real, you have to be able to monetize and advertise your excitement to other people's interests. Finally, I have to say that it's up to us engineers and entrepreneurs to get more people interested in space. We have to roll up our sleeves and do the hard work. Otherwise, we will be the generation that just procrastinated everything to the next. This is why I think programs such as this space study program should be supported and encouraged. So thank you for this invitation. I would also like to thank everyone at the Imaginarium of Technology and MIT Media Lab who helped me with this video. Thank you so much.